This is Professor Bittinger, and this is a short video lecture pertaining to solid and hazardous waste for the environmental science course. On the screen in front of you is a list of key terms associated with solid waste and hazardous waste. One I would like to draw your attention to is integrated waste management. Please look over the other terms and make sure that you're familiar with them. A solid waste needs to be defined. It's any unwanted or discarded material that is not a liquid or gas. The graphic on the right depicts the various percentages of the waste stream that is generated here in the United States. A majority of the waste, 98.5%, is the mining and oil and gas production, plus agriculture, plus industry, and sewage sludge, which is 1%. These four categories comprise 98.5% of the waste that is disposed of here in the United States. You and I only comprise about 1.5% of the waste disposed of in the United States, and that's called municipal solid waste. Each year, about 1,600 pounds per person are disposed of. Now, from a global perspective, the United States produces 33% of the world's solid waste, although we only represent 4.6% of the world's population. So we have a small population, but yet we generate a third of the waste in the world. This just, again, feeds into the concept that we are a high waste society. In fact, we have the world's highest per person or per capita solid waste production. So let's talk about the different types of waste. Solid waste is broken into two categories: hazardous waste and non-hazardous waste. Hazardous waste consists of anything that can be designated as flammable, toxic, corrosive, or reactive. And it can come in a liquid, solid, or gas form. Currently, our developed countries are the ones that produce the most. About 80 to 90% of hazardous waste is created by developed countries. The largest amount of hazardous waste is created from industry, in particular the petroleum and the chemical industry, which produces about 70% of all the hazardous waste in the United States. As far as global production, the largest producer of hazardous waste is the United States, but China is running a close second. The most common examples of hazardous waste from industries include solvents used in cleaning, wastewater from petroleum refineries, and ash produced from incinerators or coal-burning power plants. Industrial solvents, hospital medical waste, car batteries, household pesticides, dry cell batteries, ash, and sludge also counts as hazardous waste. The second category of solid waste is non-hazardous waste. Non-hazardous waste is municipal, residual, industrial, construction, demolition, and sludges that do not meet the criteria for a hazardous designation. Hence, they are not flammable, toxic, corrosive, or reactive. There are some exceptions to these definitions, and that is domestic sewage and industrial wastewater, because they are regulated under the Clean Water Act. I also have separate categories designated for nuclear waste, and nuclear waste is self-explanatory, but it's radioactive materials that are widely used in our society. The Department of Energy estimates that over 3 million packages of radioactive materials are shipped each year within the U.S. Materials are used for food preservation, medical diagnosis, agriculture, power generation, and more. I will talk more about nuclear waste later on in our short video lecture for this chapter, but I do want you to be aware that there is nuclear waste stemming from our nuclear power plants that are located throughout the United States. This spent fuel from nuclear power plants must be stored up to 10,000 to 240,000 years, and currently we really don't have any long-term permanent safe disposal practices in place for our nuclear industry. The last item on the screen pertains to medical waste. Concern for the potential health hazards of medical waste grew in the 1980s, after medical wastes were washing up on several East Coast beaches. The U.S. Congress enacted the Medical Waste Tracking Act of 1988. This was a 2-year federal program in which EPA put into place requirements for the management of medical waste. In 1991, this act expired, and as a result, there are currently no federal regulations covering medical waste identification, transport, treatment, or disposal. Now, most states have developed their own medical waste management programs, and it's really upon the shoulders of the states to enact any kind of medical waste tracking requirements or disposal requirements. Now, that being said, the Center for Disease Control, or the CDC, as well as the Occupational Safety and Health Administration, or OSHA, and the Food and Drug Administration do get involved with the state's regulatory framework for medical waste, even though they are federal agencies. So how do we currently handle our medical waste here in the United States? As mentioned previously, it's up to the individual states to set forth their own requirements on how it's managed and tracked and disposed of. Prior to 1997, more than 90% of the potentially infectious medical waste was actually incinerated or burned. In 1997, the EPA put into place strict regulations regarding the emission standards for medical waste incinerators, mainly because of the concerns over potential air quality impacts from burning medical waste. The incinerators were called Hospital Medical Infectious Waste Incinerators, or HMIWIs. Because of the more strict laws that were passed, the HMIWIs were being phased out for other less impacting ways of disposing of medical waste and ways in which it wouldn't impact the air quality. Other ways that we can deal with medical waste is through alternative treatment and disposal technologies. So, for example, doing thermal treatment to the medical waste, such as a microwave type technology, will help to stabilize the medical waste and render it harmless. Also, steam sterilization, such as autoclaving, electropyrolysis, as well as chemical mechanical systems. These alternative treatments are generally used to render the medical waste non-infectious, and then the waste can be disposed of as a solid waste in landfills or an incinerator. Again, many states have regulations requiring medical waste treatment technologies to be certified, licensed, or regulated. The EPA does have jurisdiction over medical waste treatment technologies, which claim to reduce the infectiousness of the waste by using chemicals. This jurisdiction comes from a law called the Federal Insecticide, Fungicide, and Rodenticide Act. So there's quite a lot of overlap when it comes to medical waste regulations. It's at the state level, but it can also be with the federal level with the EPA with the FIFRA, Federal Insecticide, Fungicide, Rodenticide Act, as well as with the FDA or with OSHA or the Center for Disease Control. So we've got federal agencies involved with it, but most of the burden on regulating medical waste falls on the shoulders of the state agencies. Now, as far as pharmaceuticals are concerned, in 2015, EPA signed a new rule for the management of hazardous waste pharmaceuticals. Until the new rule is finalized and adopted by the authorized states, healthcare facilities and other business entities that generate pharmaceutical hazardous waste must manage these wastes in accordance with the hazardous waste generation requirements. So, let's talk about municipal solid waste in general. I've just defined different types of waste in terms of hazardous or non-hazardous, as well as nuclear and medical, and we're going to focus on the municipal solid waste portion of the non-hazardous waste. Over the years, the amount of MSW, or municipal solid waste, generated in the United States has grown steadily, partially because of our growing population, but really because of our changing lifestyles and our increasing use of disposable materials and excessive packaging. The graph on the bottom right depicts MSW generation rates from 1960 through 2014. And the yellow dots indicate per capita generation on a per person basis, and the green dots indicate the total MSW generated in millions of tons. So we've seen a steady increase in municipal waste generation over time since the 1960s. Now, as far as a per capita basis, back in 1960, a per person basis for municipal waste was about 2.68 pounds per person. Then in 1985 it went up to about 3.83. The highest point that it's been has been 4.74 pounds in 2000, and we've recently declined to about 4.5 pounds here in 2014, actually 2017. It's off the end of the graph. So it's almost just slightly under double what it was in the 60s. And again, the main contributing factor to this is the excessive packaging that we have with our products, as well as the increasing use of disposable materials. By weight, the largest waste component in MSW is paper at about 27%. Then yard waste at about 13%. These two types of waste, yard waste and paper, coupled with metals at 9%, glass at, let's just say, 5%, and plastics at 13%, make up about 67% of our waste. So over 2/3 of our waste, yard trimmings, paper, metals, glass, and plastic, is recyclable. And that's really important to stick with that point, that over 60% of our waste that we generated is entirely recyclable. So next I'd like to compare some numbers over a 6-year period from 1998 to 2014 pertaining to municipal solid waste. In 1998, about 55% of our MSW was disposed of in landfills. 6 years later, in 2014, we tracked about 52% was disposed in landfills. So we've decreased the disposal in landfills by 3%. That's really not that much, and we can do better than that. In 1998, about 28% of the material was recovered for recycling and composting. 6 years later, 35% was recovered for recycling and composting. So we're doing better on the recycling and composting. But still, we've got almost the same amount of waste going into a landfill. And that's because we're continuing to generate more waste. Then in 1998, about 17% of the waste was combusted. And 6 years later, we've actually seen a decrease in the amount of combustion of waste, down to 13%. So in that 6-year time frame, we saw a 7% increase in recycling, a 3% decline in landfilling, and a 4% decline in combusting. In general, over the last 10 years, the landfill component has been declining, and the recycling has shown a steady increase. However, the recycling is not occurring as much as it could be, based on 67% of our waste being recyclable. Again, the yard waste, the paper, the metals, the glass, and the plastics. In 2014, about 90 million tons of MSW were recycled or composted. This is about 35% of the total waste generated. We still have at least 30% more that we could be trying to recycle. The waste disposal practices in other countries vary. One example is Japan. It's a heavily populated country, and over 75% of the trash is burned because there's less open space for landfills. Most Western European countries deposit less than half of their municipal solid waste in landfills and combust most of the rest. As far as the U.S. is considered, New York, New Jersey, and Missouri are the highest net exporters of waste to adjacent or nearby states, and Pennsylvania is one of the highest net importers of solid waste. The point I'd like you to remember from all of this is that we should take every effort to reduce our waste first, but what we do produce, we must dispose of in the most effective and efficient way in order to protect the environment and people. So the U.S. is considered a high waste society. Each year we dispose of 2 billion disposable razors, over 3 million cell phones, 18 million computers, 8 million TV sets, 1.5 pounds of edible food, 186 billion pieces of junk mail. These are just some simple examples. As far as computers and other electronics, it is considered to be the fastest growing solid waste problem in the United States. And that's because e-waste can contain heavy metals such as lead, mercury, cadmium in some of its parts. We'll talk more about e-waste later on in this short video lecture.